Hello, Math Studies students, and welcome to your online lesson. Today will be all about factoring quadratic equations, specifically with no a-term value, and we'll talk about that in a few slides. And our goal is to be able to efficiently factor quadratics with no a-term in order to create two binomials. Our first thing we want to talk about is what is a quadratic equation. So quadratic equation is going to have some x's in it. It has to in order to be a quadratic equation or expression below. And at least one of those x's has to have an x squared. And that should be the highest order or power of any of the terms that we have here. So you'll notice there's another x that we have, and that one has no exponent, which implies that there's a 1 there. And then there's our c term, which is just a constant. And then before any of our variables, we can have this a term, which is just the coefficient of the x squared, or we can have this b term here, which is the coefficient of the x. And then generally they are set equal to 0 if we write it as an equation. If we have it as an expression, the only difference is there's no equal sign, but again, we still have that x squared term, and we still have an x and a constant. Now, any of those could go away. The important thing, again, to have a quadratic is it must have an x squared. Must have an x squared. If I just write x squared equals 0, I've got a quadratic because it has an x squared. If I write 2x squared equals 0, again, I've got a quadratic equation. 2x squared plus x, still quadratic, but if I write x plus 2 equals 0, that's a linear equation because it has no x squared. Also, if I were to write something like x cubed plus x squared equals 0, again, the highest order now is a 3. That's a cubic. It's not a quadratic. It's not what we're covering in this video. And again, neither are linear equations. So what we're going to be focusing on today is factoring, sometimes called factorizing, an equation, and it's essentially undoing a binomial distribution. Now, distribution is something we've learned about in late middle school or maybe algebra class, where you're multiplying. It's like super multiplication. You're multiplying something to something else in parentheses. And what we want to be able to do is we want to turn a quadratic equation back into a pair of binomials, which is how they are generally formed. The reason for doing this is to help us more easily solve the equation, and we'll look at solving in a different lesson. But here we just want to focus on this art of undoing. Just like we do in most math, we learn about addition and then we undo it with subtraction. Multiplication gets undone with division. Squaring undone with square rooting, and now factoring is going to undo this distribution. So we're going to start off with looking at a pair of binomials. And so these are binomials. We call them binomials, bi meaning 2, because each one of these sets of parentheses has 2 terms in it. And they're not like terms, so we can't add the x and the 2, so we'd have to keep both of those terms. And we're simply going to multiply those together. Now, sometimes it's called distribution. Sometimes it's called FOIL. And it's called FOIL as an acronym, which stands for first, outer, inner, and last. And so the first terms that we're going to multiply are the x times the x. Notice they're the first of each of the binomials. Again, the binomials are these sets of parentheses, 1, 2 sets of parentheses. And if I take the first term from each of those, I get x times x. When you multiply something by itself, it becomes squared. Now I'm going to do the outer terms. I'm going to do the same x, but now I'm going to go all the way to the outside to that 3, and that's going to become 3x. Now I'm going to do the inner terms, which are the ones in the middle here. So I'm start moving on to the 2. So I'm going to multiply the 2 by the x. And then finally, I'm going to do that 2 times the 3 as well, which gives me 6. Now you'll notice here, both of these terms in the middle have x's, so they can be combined together. So we have x squared, it's the only x squared we have, plus 5x plus our 6. And that right there is binomial expansion. And you'll notice our final answer here has turned into a quadratic. It's got that x squared, which makes it a quadratic expression. There's no equal sign, so it's not a quadratic equation, but a quadratic expression. I'm going to do that one more time, and this time I'll just kind of say, what if we take the x and multiply it to both of the terms? And we take the 2 and multiply it to both of the terms. And you'll notice it was still that same pattern. I did the first, and then I did the outer, and then if I do the 2, that's the inner, and then finally the last. And you get the exact same thing. We get x times x, which is x squared. The outer becomes 3x. The inner is the 2x. And last but not least, we have the 6. We combine these like terms to get us x squared plus 5x plus 6. A quadratic. So now what we're going to do is we want to factor the following expression. And what that means is we want to work backwards. We want to end up with a pair of binomials. And binomials were those things we saw on the last screen that had x plus some number and then x plus some other number. And I could multiply those together using that distribution, to each of these terms, just like we did before, and we could turn it into a quadratic. Now, in our learning intention, we talked about factoring quadratics with no a term. You'll notice here that there is no number written in front of the x, which means there really is a number. It's an implied 1. But again, it's a very different process when there's numbers greater than 1 that we need to deal with. So on the next slide, I've got some steps that we're going to use when we go back to that previous example to actually figure out how to factor this thing. So steps to factor a quadratic with no a term value. First things first, we need to make sure the equation is in this form. Number 1, is it a quadratic? Does it have an x squared? Second, is there no number written in front of the x squared, which implies that, again, there's no a term or an implied 1. Then what we're going to do is we're going to list the pairs of factors that can multiply to the c term. So we're going to look at this c term and list different pairs of numbers that I could multiply together that would equal it. Third step, we're going to find the pairs of factors from that step that we can add together to equal the b value. That's the coefficient of x. So again, we want to find numbers that multiply to be c, but add to be b. Then we're going to take those two numbers and we're just going to plop them into our parentheses. So we'll put one number here. I'll just call it for now, put a question mark there. And then our second number will go there. We'll put our two numbers that we figured out, again, that add to be, that add to be b, but multiply to be c. And we'll do that in the opposite order. And then we can always expand it and use our binomial distribution to once again check to see if we did it correctly. Again, you can pause the video at this point to stay on this slide to copy that down. It's a very useful set of steps, but you'll see me do it on the next two examples. So we want to factor this quadratic expression. The first thing we have to do, is it a quadratic? Well, it has an x squared. Is there no a term? There's no number written in front of the x, so there's an implied 1. So we're good to go as far as that goes. First step done. Now we're going to look at our c term. Our c term is 6. So I want to list all the numbers that could multiply to be 6. Well, let's start with the lowest number. And again, only focusing on whole numbers. So we have 1, and 1 times 6 gives me 6. Then the next biggest number that goes into 6 or divides evenly is 2. And 2 goes into 6 3 times. So again, you can think of this as 6 divided by 2 equals 3. Or what number times 2 equals 6? 2 times 3 equals 6. Now as I go to the next highest number, it's 3, but you'll notice I already had a 3, so I'm repeating myself. So those are the only factors. You've got 1 times 6 and 2 times 3. 4 doesn't go in evenly, 5 doesn't go in evenly, and then 6 we're back up to the highest number itself. So there's just two pairs of factors. Now I want to check which one of these pairs of factors adds to be the 5. So again, we figured out which numbers multiply to be 6, but then add to be 5. And that would be these right here, 2 and 3. So I'm going to write down now, I know there's an x and an x here always, because x times x gives me x squared. And then I simply copy these two numbers here. They're both positive, and I'm putting plus signs for that. And voila, I have factored. I have factorized this quadratic into two pairs of binomials, which was exactly the goal of this lesson. Now again, I can always check it. This is my answer, but I can check it using the FOIL. I do x times x, which is x squared. I can do x times the 3, which is 3x. And you'll notice this is the exact same expression we had before, except we're just working backwards. And now I can do the 2 times the x and the 2 times the 3, which gives me 2x and 6. And then I have a 5x here, 6, and x squared. So that's what I started with. So I can undo it and then redo it so I know I did it correctly. And so again, that was the goal of our lesson, was to be able to take a quadratic equation, turn it back into the binomials that created it. We're going to do one more example like that. And so this time, I've got an equation this time, but we're not going to worry about the equation. The equation is just the exact same thing. X squared plus 7x plus 12 equals 0. So my first step is to look at my C term. And again, we've confirmed, of course, that it's already a quadratic. It has no A term here. And my C term is 12. So I'm going to, again, list all of the factors for 12. Start with the lowest. I've got 1. And again, times 12, I could equal 12. 2 also goes into 12. 2 times 6 equals 12. 3 goes into 12, and 3 times 4. And if I try to do the next number, it's a 4, but I already have a 4, so I've already gone through all my possible values. Numbers such as 5 or 7 do not go into 12. So that is my list of factors. Now I want to check which of these factors, again, we know they multiply to be 12, our C term, but which of them add to be our B term. 1 plus 12 equals 13, and again, our B term is just 7, so that's no good. 2 plus 6 is going to get me up to 8 when I add them, and again, my B term is 7, so that's no good. And then if I do 3 plus 4, that does give me 7, and that's what I'm looking for. So for my final answer, I've got x plus 3 and x plus 4 as my final binomials. Again, 2 sets of 2 numbers or terms in each of these. As always, that's my final answer, but I can still check it. Go ahead and distribute. X times x gives me x squared. X times 4 gives me 4x. My inner terms are going to be 3x. And then my my last terms are the 3 times the 4, and I get 12. I can combine these like terms here to get me x squared plus 7x plus 12. And that is the exact same thing we started with. Now, the one thing I forgot to mention is because this is an equation, we should have an equal sign at the end of all of these. But you don't need to worry about that for now. We're just adding that on. All right, and that is factorizing. So again, our goal was to be able to factor quadratic equations with no A terms. We have successfully done that. And again, we have created 2 binomials. Till next time.